In this video, I'm going to be demonstrating one method for deriving an interval class vector, or ICV. Now, this video won't be going into much detail on how or why interval class vectors are used, just on how to find one. I'm going to show every step of the process that I use, but once you get the hang of it and understand the general concept, you'll be able to skip a lot of these steps and considerably shorten the process. So, to demonstrate, I'm going to use this group of pitch classes. It happens to be a second-order all-combinatorial hexachord, but that actually doesn't matter for this video. Now, this hexachord's interval class vector, or ICV, is 420423. Here's how to get there. I like to start by drawing what would be a circle of fourths or fifths, but to instead map a chromatic scale onto the circle, as you see here. Now, if you're familiar enough with integer notation, you can alternatively just draw a clock face. But remember, use 0 instead of 12, and E for 11, and T for 10. That way you won't inadvertently get mixed up between 10 and 1 and 0, or 11 and 1 and 1. The clock face and the chromatic circle represent the same thing, the notes, and we're going to use it to count intervals. In case you're unfamiliar with integer notation, I'm going to combine the clock face and the chromatic circle. Just know that it's redundant information to have both at the same time. Once the clock face / chromatic circle is drawn, I like to draw the following table. Notice that the table has the same amount of rows and columns as number of pitch classes. There are 6 pitch classes, and 6 rows, and 6 columns. On the left side of the table, write intervals from X, X being the pitch names from your set of notes. So, an interval class vector describes the intervallic content that is present within a group of pitch classes. And to remind you, pitch classes and pitches are different. Unlike pitches, pitch classes have enharmonic and octave equivalency. If that confuses you, check out my video on pitch classes. Okay, now that we're totally set up, it's time to start counting. I'll show the first row, intervals from C, step by step, and then speed through the other intervals. First, count the interval between C and C sharp. The interval between C and C sharp is 1, or 1/2 step, or 1 semitone. So, let's put a 1 in the second column of our new table. Next, count the interval between the first note, C, and the third note, D. Now, do the same thing for C and F sharp. And for C and G. Okay, here we've run into a problem. Notice that if we continue counting left to right on the circle, that G is 7 half steps away from C. That number 7 is the problem. Because ICVs are only concerned with pitch classes and not pitches, we only want intervals that are 6 or less. So, for intervals that are larger than 6, we need to count by going the opposite direction on the circle. Or, in other words, we need to invert any interval that is larger than 6. If this is confusing, watch my other videos on inversions or pitch classes. But just remember, if you end up with any interval that's larger than 6, you need to invert it, or count going the opposite direction on the circle. Another way to avoid this problem is to draw a straight line between the note name that you're counting from to the note 6 half steps away. This will always divide the circle in half, and therefore also divide the octave in half. I'll draw the line now, and also draw it for the remaining rows. And finally, C to A flat. And that's it. Easy, right? Now I'm going to speed through the rest of these intervals without commentary. Feel free to follow along. Now that our table is filled out, we need to count the number of occurrences of each interval. Let's draw one more table to help us keep organized. There will be 2 rows in this table, each with 7 columns. In the leftmost column, write interval in the top box and number of occurrences in the one below that. Now, let's count the number of times the number 1, or interval of a half step, appears in our original table. Alright, we have 4 ones. Now it's important to remember that 1 is actually an interval, a half step. Since we have 4 half steps, put 4 in the corresponding box on the new table. Now, let's count the amount of times the number 2 shows up on our table and put that number in its associated box. Because there are no 3's in our table, let's put a 0 for that corresponding box. Now, let's do the same thing for the 4's, 5's, and 6's. Great! And that last string of numbers there is actually our interval class vector. Thanks for watching, and be sure to leave a comment if you have any questions.